Hello, check. All right, people. I believe we are live once again. Welcome to Catalysis by Vedantu. If I'm audible and visible, please write you in the chat box. You know the drill. Yes. और बताओ दोस्तों क्या चल रहा है लाइफ में? Everything going good, I hope. Yeah. So, people, today is yet another class of Redox Reactions, and after this class, Redox Reactions basically is over. But we'll see if we need to do another class on basics of electrochemistry, which I've already done. So dekhte hain if that's necessary, but most likely it's not necessary because we've already covered it a few days back. So today is about titrations. Yes, and I told you a few days back that advanced level titrations would be covered in this week, and once I cover the advanced level titrations, then I will take a specific class on just question solving for these titrations. Okay? So today is one of those classes which covers the advanced topics of titration. So before that, let me cover the homework for you. Yeah, some people remember that this is the homework that I had given you on Friday. Yeah, yesterday, people, long story short, my flight got delayed. Nothing else. Hua ye that I was supposed to have a flight at 9 in the morning, but it got delayed to 9 at night. So couldn't do anything. Yeah, that's the only reason. Anyway, so ye hai aapka question. So this is just a disproportionation reaction. Let's quickly solve it. I can write Cl2 plus Cl2 goes towards ClO negative plus Cl negative. So over here, your chlorine is going from 0,0 oxidation state to -1 oxidation state. Yes, and what's the oxidation state over here? +1, isn't it? Yeah, +1 oxidation state. Oxygen is supposed to have -2. One is here, one is here. Yeah, and why have I written these 2's next to chlorines? Because you've got 2 chlorines on the left hand side. Cl2, Cl2 going to 2 times ClO negative plus 2 times Cl negative. Yeah, so 2, 2, 2, 2. Fine. Now let's balance the electrons. This is 1 electron per chlorine. So this is a 2 electron process. This is what? This is also 1 electron per chlorine. So this is also a 2 electron process. So the electrons are already balanced. Yeah. Since 0 is going to -1 and +1, of course, it is already balanced. So इसके ज़्यादा करने की ज़रूरत नहीं है. You would realize that this reaction is already balanced. देखा जाए तो है ना. अगर इसको मैं ऐसे लिख दूँ, this is 2 times Cl2 going towards this. So there's no need to write 2 either. Yeah. This reaction is such that electrons are already balanced. है ना जी? तो ये तो पहले से ही balanced है. The only thing that we need to do is we need to create an extra oxygen on the left hand side in the alkaline medium. So how will we do that? We'll simply add 2 times OH negative, and on the right hand side we can add an H2O, and I think we're done. Isn't it? So a very, very simple homework I had given you. Let me see how many of you were able to give me the correct answer. Let's open the chat box of the previous class. I mean the comment section. Let's sort the comments by newest first. Chalo bhai, dekhte hain kya chal raha hai. Okay, just a second. It's loading. Huh. So Cl2 plus 2 times OH negative gives you ClO plus Cl negative plus H2O. Pretty much. So Gaurav, absolutely correct. Ibrahim, yes, that is absolutely correct. Nivedita, yes, that is absolutely correct. Badhiya. Nivedita, don't worry, it comes as a strikeout because of this arrow symbol. I don't know what's wrong with YouTube. Abhirup, yes, that is correct. Congratulations. And good. Please write your original name over here. Thank you so much. Suhani, okay, thoda idhar udhar ho gaya. Suhani, you should have written the OH negative on the left hand side. Anyway, I hope you understood what's going on. Arya, that is absolutely correct. Yeah, Parth, I know, right? Diyasa, yes, that is correct. And Kevin, हाँ ठीक है दोस्त, your answer is correct. Just divide the answer by 2. But your process is absolutely correct. That's fine. And Ravi, yes, that is correct. Suhani, I'll have to check that question once again, yaar. Okay. Chalo, anyway, people, lots of you gave the correct answer. Nishit is also giving the correct answer. Yogita, badhiya. So if I start taking the names of everyone, then the entire class will go in the names only. Anyway, good job everyone. If you got the answer correctly, high five. Chalo, अब चलते हैं दोस्तों titrations की ओर. Let's go towards titrations now. And have you attended my class of ionic equilibrium previous week पे? Yeah. Did you do that? Where I was teaching you about titrations. Remember what is titration? Titration में you take an unknown species in the flask and you take a known species in the burette. This is something that we have done already in the ionic equilibrium chapter, so I am hoping that you people have watched that class. Yes. So you have a known solution here, unknown solution here. Ultimately, you are trying to use the properties of the known solution to figure out what's going on with the unknown solution. So titrations may, if I talk about the mathematics, what was the mathematics that is necessary? Okay. Equivalence. Okay. Equivalence of acid are equal to equivalence of the base. Do you remember this idea? Yes, people say yes or no in the chat box. Tell me. Yeah, equivalence of acid equal to the equivalence of base. This was the idea used to solve acid base titrations. Yeah, acid base titrations. But over here we are supposed to do redox titrations. Right? So the funda of equivalence in redox is a little different. Okay. Titrations के लिए, for titration, the formula, the basic logic that you will use is exactly the same. Equivalence of species 1. Okay. क्या spelling लिख दिया मैंने? Okay. Equivalence of the first species have to be equal to the equivalence of the second species. Okay, or I can simply say that equivalence of the oxidizing agent, OA means oxidizing agent, are equal to the equivalence of the reducing agent. Yeah, I can say that. So this is the basic idea behind any titration. Yeah, you've got two halves of the reaction. Both the halves should be equal in terms of their equivalence. Yeah. For example, if I'm titrating Fe to positive with, let's say, KMnO4, we'll see this example today very soon. The equivalents of iron have to be the same as equivalents of KMnO4. Fine. This is the idea. Now, how do we calculate the equivalents of redox reactions? Whenever we are talking about redox reactions, my dear friends, in acids and bases, yeah, when we were figuring out equivalents of acids and bases back in mole concept chapter, let's think about what is the property, what is the physical quantity with which they react. सोचेंगे. For acid, what is the physical quantity with which it reacts? Let me give you the answer so that you understand what I'm trying to ask. H positive, yeah? The number of H positives decides what is the equivalent factor for an acid. Yes. For example, if you've got HCl, the equivalent factor or valency factor is 1. For H2SO4, equivalent factor is 2. For H3PO4, equivalent factor is 3. Remember this jazz? Yeah, because this has 1 H positive, 2 H positives, 3 H positives. So acids react by the virtue of H positives they can provide. And that number is equal to the valency factor. Now if I talk about bases, then what's the quantity that I'm looking for? For bases, I'm looking for OH negatives. Yes. Acids के लिए H positive, bases के लिए OH negative. Now, let us think about redox reactions. What should we look at in redox reactions? For acids, we look for H positive. For bases, we look for OH negatives. In redox reactions, there is one thing that we balance. What is that? Aviral, you are on almost the right track. Yeah? You're almost on the right track. Ishani, the thing is, we've already covered an entire series of advanced level questions for each and every chapter. So I'd suggest you look at that, because right now I'm trying to teach in a manner that everyone is able to understand. Yeah. Kevin is saying electrons. Very nice. Nivedita is also saying electrons. Beautiful. Yeah. IIT aspirant, can you please wait for your question. It's not relevant to the chapter, so I'll answer it later. Okay. Tobirama Senju, yes, absolutely. Electrons, bilkul sahi baat hai. In redox, you have to look for electrons. So honey, when we'll solve questions, your doubt will be answered, don't worry. In redox, we need to look for electrons, right? How many electrons are you exchanging? How many electrons are you taking? Yeah, isn't it? A very simple example would be if species A is going to A5 positive plus 5 electrons, and there is a species B which captures 1 electron to become B negative. How many B's can react with 1 A? Simple as सवाल है. Yeah. If this is your oxidation half, yeah. If this is your reduction half, yeah. If 1A provides you 5 electrons, how many B's can react with 1A? Isn't it obvious? 5 B's will react with 1A. क्योंकि उसको 5 इलेक्ट्रॉन मिल जाएगा. So the ratio in which these redox reactions happen are the ratio of electrons. In acids, the ratio of H positives, and bases, ratio of OH negatives. Over here, ratio of electrons. As simple as that. So this is the equivalent factor. This is the equivalent factor for redox species. For example, if I look at A, this is what? A 5 electron process, isn't it? Since this is a 5 electron process, the valency factor for A is equal to 5. As simple as that. So this implies 1 mole of A is equal to 5 equivalents of A. And in case you've forgotten what is the equivalent concept, please go back and watch the classes of the mole concept chapter. ठीक है? अगर आप लोग भूल गए हो, in case you have no idea what equivalents are, yeah, in case you are totally confused, equivalent ka hota hai sir, then all you need to do is go to the playlist section of our channel. Okay, let me move my face to one side. Go to the playlist section of our channel and just scroll down. Or yahan pe there is going to be this particular series called the epic mole, and over here I have taught the equivalent concept in one class. Just watch that. Pretty sure you will become good at the equivalent concept. So make sure you check it out in case you do not have an idea of equivalents. Fine. So 1 mole of A is equal to 5 equivalents of A. That's the idea. Let's solve a question now. Let's not waste any more time. Calculate the number of millimoles and milliequivalents of Cr2O2 negative ions in acidic medium when 100 ml of 0.01 molar Cr2O72 negative is reduced to Cr3 positive. So the very first thing that we need to do over here is figure out the equivalent factor, the valency factor. Okay? So Cr2O7 2 negative goes towards Cr3 positive. Now we already know how to balance redox reactions. Yes, if we are starting with 2 chromiums, we are going to end up with 2 chromiums. Can I break this apart into 1 chromium atom? No, because this is a part of the entire molecule. Yeah, this entire molecule has 2 chromiums. So you cannot break apart this Cr2 into 2 Crs. Okay, you cannot break apart an S8 and write it as S4 plus S4. No, this is incorrect, because S8 is 1 molecule. Someone had asked me this doubt. If you are attending this class, I hope it is clear now. Okay, so isko todna nahi hai. So this Cr2O7, this entire thing is a molecule. That molecule, when it reacts, then it is breaking apart into 2 different chromium atoms. So over here on paper we shouldn't write Cr plus Cr. No, this is not correct for the left hand side. Okay, if you have to write something, then you can write Cr2O7 2 negative plus Cr2O7 2 negative. You can multiply the number of molecules that you are taking on the left hand side to balance the reaction. Anyway, so now my dear friends, this process, as you all know, how many electron process is this? This is what 7 to the 14, 13, 12, 12 by 2. This is a plus 6. So this is a 3 electron process per chromium atom. But do you realize we are talking about the entire molecule over here? This entire molecule is undergoing the reaction. So for this molecule, what is the equivalent factor? What is that Z factor for this entire molecule? For this entire molecule, I can write, since there are two chromiums, two chromium atoms, so 2 into 3 electron process is a 6 electron process. So this entire process is a 6 electron process. Okay, process per molecule of Cr2O7 2 negative. Get the idea? You have to think about how many electrons is the molecule exchanging. The entire molecule is exchanging 6 electrons in this process. Got it? Nikhil, there are other ways to ascertain whether this is a live session or a recorded session. It says live on YouTube. Dost, please join the class from the beginning. भरोसे का ज़माना ही नहीं रहा आज. Okay, chalo. So this is a 6 electron process per molecule of Cr2O7 2 negative. So my dear friends, what is the valency factor for Cr2O7 2 negative? Valency factor is equal to 6. Okay. In redox reactions, valency factor is as good as the number of electrons involved in that process per molecule. You just have to look at the number of electrons involved in a process per molecule and that will give you the answer for your Z factor. ठीक है? चलो, अब आगे बढ़ाते हैं इस question को. Let's, after we know this information, let's solve the rest of the question. So you've got 100 milliliters of 0.01 molar Cr2O7 2 negative. Everyone should know this. Molarity into volume gives you number of moles. Molarity into milliliters will give you number of millimoles. Molarity into liters gives moles. Molarity into milliliter gives millimoles. Yes. So how many millimoles are there? I've got 1 millimole. Isn't it? 100 into 0.01. 1 millimole of Cr2O7 2 negative. And since the valency factor is equal to 6, I can write that this has 6 millimoles of Cr2O7 2 negative. As simple as that. Sorry, millimoles क्यों लिख दिया मैंने यहाँ पे? 6 milli equivalents of Cr2O7 2 negative. चलेगा? Got it? हाँ या ना? Is that right? Is that wrong? You got to tell me. Everyone in the chat box, it's a humble request from my side that number one, please ask doubts that are related to the chapter. Other doubts I can take later only. I don't want to finish the decorum of this class. If you're sitting in a classroom in front of a teacher, will you start shouting in the middle of the class and say random things? No, right? You need to focus on the question. So please focus on the question that we are doing right now. For all of you who are asking how to improve your preparation, focus. Okay? Cool. Rotash, we've done hydrogen chapter already. Saurabh sir has taken that chapter earlier. ठीक है? Fine, people, got it? कोई doubt हो तो बता देना. Yeah, please tell me if you've got any doubts. Anyway, this is done. Let us move on into the next question now. If you're able to solve this question properly, you are 99% done with all sorts of titration. Okay, so please focus on this particular question. While I'm solving this question, I'm not going to look at any doubt in the chat box. Okay, we need to be focused on the question right now. So please, if you guys are worried about anything else in your life, Forget about it, focus on the question. This is gonna help. Chalo. So 20 milliliters of FeSO4 solution is titrated with 0.02 molar acidified solution of KMnO4. What it means is that you took a 20 ml of FeSO4 solution inside the conical flask and in the burette on the top. Yeah. Over here, you had taken the solution of KMnO4 and you required 24.3 milliliters of this solution of KMnO4. Okay. And what is the information about it? The information is that this is 0.02 molar. Fine. So this is what's going on. KMnO4 has been taken in acidified conditions, 0.02 molar concentration, and its 24.3 milliliters was required to do the complete redox reaction, to do the complete titration against 20 milliliters of FeSO4. Over here, what is the molarity? I have no idea. That is why this is the unknown solution. Yes, this is the unknown solution, this is the known solution. Fine. Now, this was required to reach the endpoint. Determine the molarity of FeSO4. So this is the picture that needs to come in your mind. Once you've drawn this picture, let me write it in a much more calculative form. So what I'll do is, I will write on the left hand side, we'll talk about FeSO4. On the right hand side, I will talk about KMnO4. Chalo ji likhte hain. What is the species that is reacting over here? FeSO4 is basically containing Fe2 positive. है ना जी? What is the main species that is reacting over here? Manganate, sorry, permanganate, yeah, MnO4 negative, right? Now, one piece of information that you have to remember: MnO4 negative, when it is in acidic conditions, all right, when you provide it acidic conditions, it turns into Mn2 positive. Okay, this is something that we had discussed in the very first class of redox reactions also. Yeah, while I was balancing that redox reaction for you, you asked me, sir, how will we know whether it is acidic condition or basic condition? And I said that it will either be mentioned or some hint will be given that tells you whether it's acidic or basic condition. So MnO4 negative under acidic conditions turns into Mn2 positive. Fine. That is what's going on over here. अगर आपको सोचना है what happens to it in neutral conditions, in neutral conditions it goes towards MnO2. In very basic conditions, okay, very basic, neutral, slightly alkaline हो तो भी MnO2 में convert होता है. If the condition is neutral or slightly basic, then it turns into MnO2. If it is very basic, then it turns into MnO4 2 negative. Okay, this is the information about MnO4 negative. Permanganate, when you take in acidic conditions, turns into Mn2 positive. When in neutral conditions, turns into MnO2. And in very basic conditions, it turns only into MnO4 2 negative. This is experimentally verified information. Please note it down. Now, my dear friends, over here in the first case, acidic case, this is manganese plus 7. How many electron process is this? This is a 5 electron process. How many electron process is this? 3 electron process. How many electron process is this? 2 electron process. Sorry, 2 kahan se ho gaya? 1 electron process. So do you see that the valency factor for KMnO4 will be different in different conditions? In acidic conditions, KMnO4's valency factor is equal to 5. Okay, in neutral conditions, KMnO4's valency factor is equal to 3. In highly alkaline solutions, KMnO4's valency factor is equal to 1. Please note this information down, then we will continue with the question. Okay. Cool. Chalo. So, write this down, please. I'm giving you 5 more seconds. You can take a snapshot of this. Okay, So we just need to be considered, we just need to be concerned about the acidic condition over here, right? So in this case, I can say that the valency factor of KMnO4 is equal to 5. ये याद रखने का अपने को, valency factor is equal to 5. Fine. Now let us look at the left hand side. If this guy is going to Mn2 positive, what is this kind of a reaction? What kind is this reaction? This is, reduction or oxidation. What is this reaction? It is capturing electrons, right? So this reaction is a reduction reaction. If this is reduction, then this needs to be oxidation. Where can Fe2 positive go to oxidize itself? Obviously, it has to go towards Fe3 positive. Have you ever heard of Fe5 positive? No. Is there any other option? Iron 2 positive will go to iron 3 positive. That's the only option it has to become oxidized. So this is your oxidation process. And the fun thing is, it's just a 1 electron process, isn't it? So the valency factor over here is equal to 1. Now life is very simple. How do we calculate number of equivalents? Number of equivalents can be calculated as valency factor into number of moles. Number of equivalents is equal to valency factor into number of moles. Okay. Valency factors we figured out. How do we figure out number of moles? Number of moles is simply equal to molarity into volume. Write this over here, equate those two, you're done. Khatam. So Z क्या आएगा यहाँ पे? 1. What is the molarity? I don't know. What is the volume used? 20 milliliter. The same equation for this side. Valency factor into molarity into volume. Let's write it for KMnO4. Valency factor is equal to 5. Molarity is equal to 0.02. What is the volume used? 24.3 milliliters. Now, just equate these. My dear friends, question is done. बस ये करना है आपको. This is all we need to solve. If you solve this, got the answer. हो जाएगा. So what's the answer? क्या आंसर आ रहा है बता दो, फटाफट से खत्म करते हैं इसको. Yeah, question mark will be equal to 5 into 0.02 into 24.3 divided by 20. Giridhar is saying, can you take separate class for droppers? Why, bro? Do droppers have a different syllabus? No. By dropping, you've made sure that you are not attending any more school, you're only doing exam preparation. You can do it from the classes that we are taking. Okay. Rudra, that's exactly what I've done in the last 10 minutes. Please rewind it and watch it again. If you are not sure of what is equivalent, if you're not sure of what is titration, there are other classes that I've already taken on this channel. Please go back and revise the concepts of basic titration and equivalent concept. Where can you do that? You can do that right on our channel. If you go to the playlist called the Epic Mole Equivalent Concept, you will be able to understand what I'm doing over here. Okay. I am very sorry that I can't iron out all of your doubts because this is the end of the syllabus. Okay, and towards the end of the syllabus, if there are doubts that pertain to the beginning of the syllabus, I hope you understand it's not practically possible to do that right now. Okay, so yes, the answer comes out to be 0.01215 molar. बिल्कुल. तो ये जब calculation करोगे, you will get question mark is equal to 5 into 0.02 into 24.3 divided by 20. So the answer comes out to be 0.01. 0.12 आ रहा है कि 0.01 आ रहा है? Okay, most of the people are giving me this answer. 1215 molar. Calculation, I'm just looking at the chat box. ठीक है जी, cool. Done. और बताओ दोस्तों. Done. This question is done. Now the next question that I'll show you is very similar to this one. Okay, I will give you 2-3 minutes to work on that question. Once you've done that, try to give me the answers in the chat box, then I will solve it for you. That's going to be the last question of today's class, because if you can solve that, you're done. You're done with redox titrations as well. Very similar to this question, but a little more tricky in its nature. Let's look at this. Read it very carefully. 1.51 grams of an iron wire is dissolved in excess of dilute sulfuric acid and the solution is made up to 250 milliliters. तो क्या किया अपन ने? We took an iron wire, we dissolved it in sulfuric acid H2SO4 and then that solution is made up to 250 milliliters. Out of that 250 milliliter, 25 milliliter portion was taken and it was titrated using 0.02 molar per manganate solution. Its 25.45 milliliters was required to reach the end point. Finally, determine the mass percentage of iron in the wire. What I will do right now is I will give you guys a little bit of time to work on this question. Take 3 minutes. Solve it right now. Okay, I'll just move out of the screen. Try to solve it. ठीक है गौरव, no, I do not teach on Vedantu Pro subscription. Okay. Achyut, don't worry, they will provide you some option. Don't worry about it. Okay. निमित भाई, लेक्चर नया है, क्वेश्चन वही का वही है. अगर आपको पहले से पता है तो आप यहां से जा सकते हैं. बालाजी, yes, you are going on the right track. Gaurav, look at chlorine's oxidation state, man. Disproportionation is when you undergo oxidation and reduction at the same time. Look at chlorine's oxidation state in ClO4 negative. Do you see it can't get oxidized and reduced at the same time? ठीक है, cool. So Balaji has given the correct idea. This question has to be done backwards. Everyone else, what's your opinion? Thank you for your compliments, people. Raghav, because I'm teaching at YouTube. That's all, bro. No other reason. Anyone getting the answer? कुछ idea लग रहा है? चलो, let me take you 1, 2, 3 steps further. Okay, step by step करेंगे इसको. Let me try to give you an imagination of what's happening. So you have 1.51 gram of a wire. But the thing is that this wire is not pure. Okay, this is not 100% iron. Yeah, that's why you have to determine the mass percentage of iron in the wire. This is not 100% iron. This is some wire which has some impurity and some iron. Okay, so let us assume ये जो wire है ये it's not pure. Since this is impure, let us assume that I am beginning with X grams of iron. Just assumption, okay? This X grams of wire is dissolved in H2SO4. So when you dissolve iron in H2SO4, what's going to happen? You are going to get a solution that is FeSO4. Yeah, you know what happens when metals are reacted with acids? Hydrogen gas is liberated. So hydrogen gas will leave away. You basically end up with an FeSO4 solution that has some X grams of iron in it. Yeah, this FeSO4 solution is 250 milliliters. Now this 250 milliliters, it's a high volume. Yeah, 250 milliliters is a very huge volume. You don't need that much volume in the laboratory to do titration on it. So out of this solution, I take 25 ml of this solution. So what I have is a 25 ml FeSO4 solution. So if I'm able to determine the molarity of this solution, you will get the molarity of this solution. If you have the molarity, you would know how many moles of FeSO4 you have. If you know the moles of FeSO4, you know the moles of iron you have. If you know the moles of iron, you know the mass of iron you have. That mass can be compared against 1.51 to calculate the percentage purity. So the question basically is, find molarity of this solution. This is the question. Everything else is just ho jayega. This is the question. 25 ml of FeSO4 solution, find the molarity of that solution. So how do we do it? Same thing. Fe2 positive versus MnO4 negative. Since everything is happening in H2SO4, yeah, it was an H2SO4 solution, the entire thing is in acidic medium. There has to be some trace of H2SO4 in the entire mixture, right? This FeSO4 solution, there will be some H2SO4 as well. So the entire situation is acidic. So KMnO4, as I've told you in acidic cases, valency factor is equal to 5. This will be reducing. So this guy gets oxidized. Yeah. MnO4 negative gets reduced to go to Mn2 positive, as I showed you in the previous question. Iron will get oxidized to Fe3 positive. Valency factor will be equal to 1. Now you just have to write Z into M into V is equal to Z into M into V. Both sides, write it, you get the answer. So now step by step, try to reach the actual mass of iron in the wire and tell me what is the percentage purity. Batao. You just need to tell me what is the mass percentage of iron in the wire, how much of that wire is pure. Tell me. Balaji, you are very close. Krish, yes. So the iron wire is somewhere around 1.4 grams. Exact answer you can try to calculate. Then give me the percentage. Varun, titration questions are a little elaborate. They are not really hard. If you practice them, you will become better at them. ठीक है, चलो करके देखो. तो भी I don't think that's going to be possible. Niveta, don't worry, just try solve this question. I've already given you all the hints. ये तो सब पता ही है. Valency factor I've given you. Molarity of KMnO4 is given to you. This is what you have to calculate. Volume is this volume is 25 milliliters. This volume कितना दे रखा है? 25.45 is 25.45. आ जाएगा. Balaji saying 92.7. Very close to the accurate answer. It's fine. Very close to the accurate answer. Yeah. चलो मोलारिटी निकालो फटाफट से. Find the molarity, people. Somewhere around 92-93%. Yeah, that is fine. उतना ही आना चाहिए. Yeah. Cool. This process is clear, I hope. So let's just do the ZMV for these two solutions. So 1 into question mark into 25 is equal to 5 into कितना है ये 0.02 into 25.45. So if you want to be super accurate, then you can do this entire calculation. I'll try to do that. एक बार थोड़ा accurately कर लेते हैं इसको. Just give me a moment. Yeah, I'll just do this accurately so that we get a proper answer. So this will be 25.45 into 0.02 divided by 5, है ना? अच्छा 20. Yeah, exactly 0.1018 molar आ जाता है. So what that means is, okay, what that means is I've got 0.1018 mole, एक second, mole FeSO4. Since there is one atom of iron in FeSO4, I can simply say moles of FeSO4 are as good as moles of iron. So there is 0.1018 mole of iron in 1 liter of solution, isn't it? Can I say that? Is that fine? 0.1018 mole of iron in 1 liter of solution. So 0.1018 by 4 mole of iron in 1 by 4 liter of solution. 1 by 4 liter is how much? 250 milliliters. So over here in this particular solution, I have 0.1018 by 4 mole of iron. Where did this iron come from? All of this iron came from the wire. So if I calculate the mass of iron over here, that mass of iron is basically coming from the wire. So उसका mass calculate कर लेते हैं. How much is that? That is 0.1018 divided by 4 into 56. चलो जी, ये calculate कर लो. Accurate कर लेते हैं थोड़ा इसको. Yeah. This is 1.1425. Yeah. So this is the mass of iron in the wire. Actually, 1.51 grams was the total weight of the impure wire. This is pure iron. The rest of it is impurity. Yeah, एक सेकंड, मैंने क्या लिख दिया? 1.425. Sorry. So out of that wire, 1.425 grams is iron. Rest of it is impurity. So what is the percentage purity now? Percentage purity कितनी आ जाती है? Yeah, comes out to be 94.4 approximately. Yeah, ठीक है. So I'm going to erase everything now. If you need the explanation once again, rewind it, watch it again. Otherwise, I'll summarize the explanation for you once again. Don't worry. Okay, एक बार फिर से इसको summarize करेंगे अपन. So percentage purity is equal to 1.425, that is the actual weight of iron upon total weight of the impure substance, into 100. This comes out to be, if you do the accurate calculation, it will come out to be 94.4%. Okay? So if you got the answer anywhere in the range of 92 to 94, that's fine, because you would have done some approximation somewhere or the other. Okay? So let me again summarize the entire question for you. Okay? What happened over here was, we had an impure wire. That impure wire contains some amount of iron. I don't know what's that amount. That is the amount of iron that I have to calculate. This entire iron was converted into FeSO4 by dissolving it in a lot of H2SO4. Okay? So once dissolved in a lot of H2SO4, that solution contains FeSO4 now. Yeah? And this entire solution was 250 milliliters. but I can use a smaller quantity of it in the laboratory to do the titration. I don't need to use 250 milliliters. I can just use 25 milliliters to do the titration. So out of this solution, I took 25 ml of this solution. Basically, what's the main constituent in this solution participating in the redox reaction? That is Fe2 positive. Fe2 positive is participating in the redox reaction, isn't it? So you essentially have 25 milliliters of Fe2 positive. These 25 milliliters of Fe2 positive are reacted against 25.45 milliliters of MnO4 negative. As we know, this will convert into Fe3 positive. Valency factor is equal to 1. Molarity is something that we don't know. If we calculate molarity, we can backtrack it to the mass of iron originally. Over here, valency factor is equal to 5. As I've told you, MnO4 negative in acidic conditions shows valency factor of 5. And molarity is equal to, कितना दे रखा है यहाँ पे? हाँ, 0.02. Done. ZMV, equate that, you will get molarity. Molarity is moles of FeSO4 in 1 liter. Convert that to 250 milliliters. That will give you moles of FeSO4. FeSO4 has 1 atom of iron. So moles of FeSO4 are equal to moles of iron. So calculate moles of iron, calculate weight of iron. Once you have the weight of iron, you can calculate the percentage purity. Silokesh, you can interact with you over here in the you can interact with me over here in the chat box, or you can leave a comment later underneath the video. This is the question. Done. There is nothing more to this question. Nivedita is asking, why is atomic weight of iron given? Nivedita, when you calculate the moles of iron to convert it into mass of iron, you will have to multiply it with the molecular weight, right? That's why they've given it. As simple as that. Aviral, okay, I'll do that. I'll do that. ठीक है जी, done. So, my dear friends, congratulations. Titrations are over. This is all there is in redox titrations. All you need to remember in redox titration is Zm1V1 is equal to Zm2V2, or simply N1V1 is equal to N2V2. Even simply put, equivalents have to be the same for both the oxidizing agent and the reducing agent. Yeah, that's all. Let's not complicate it any further. What you can do now is you can try and solve some questions. Where will you find questions on redox titrations? You can find it on Google. Redox titration question practice. Otherwise, you can find it in NCERT as well. NCERT has this redox reactions chapter. Class 11th NCERT part 2. I think it is unit 7 or unit 8. I'm not exactly sure. But open it up and see. You will find a bunch of questions in NCERT related to this chapter. Technically speaking, all the concepts of this chapter have been covered. There are some more concepts related to electrochemistry. Yeah, how to create a Daniell cell, how to create a galvanic cell, etc. And I've already covered those basic ideas in the electrochemistry chapter. Okay? So if I show you where it is on the channel, if you go to the playlist of our channel, okay, this is the playlist section, and if you go over here, we've got electrochemistry. The first two classes, okay, basics of cells, EMF, etc. and lecture 2 thoda niche chala gaya hai, but it is in the playlist, okay. So lecture 1, lecture 2, EMF, Nernst equation. So in lecture 1 and lecture 2, if you watch these classes, you will be able to figure things out very easily, okay. Cool. And I have seen a lot of people ask me, sir, where is this video? Where is this video? If you're not finding anything, just go to the video section of our channel. यहाँ पे खोज लो जो भी है. Okay, might take a little bit of extra time. If you want to search for it, just use the search bar. Fine, cool. So here we are, people. Redox reactions chapter is over. So we very soon will take an advanced level class on titrations, and in that advanced level class of titrations, I will just be solving questions. Most likely that's going to be in 1 or 2 days. Okay, so in this week we will cover the advanced level redox titrations chapter. I am going to take some strategy sessions now in this particular week. Let's try to focus a little bit on how to do this, how to do that kind of a session, and eventually I will tell you how to learn organic chemistry from me. Now is the time for us 11th class students to jump towards organic chemistry. And I will let you know before anything else that there already is a very beautiful playlist of organic chemistry on YouTube, and that is called Epic GOC. It's for general organic chemistry. That's where you start your organic with. So वो भी मैं दिखा देता हूँ कहाँ से मिलेगा. If you go to YouTube, just write Epic GOC. Epic GOC search करोगे. The first playlist that you get from Vedantu JEE channel is Epic GOC. You can watch the entire thing over here. Okay, from class 1 to class 10. बहुत मस्त. It's a very amazing playlist. As you can see, it has more than 6 lakh views already. So a lot of people have benefited from it. If you want to jump into organic, this is where you need to go. चलो बढ़िया. So और बताओ दोस्तों क्या चल रहा है. By the way, in case you guys want to join a crash course for JEE 2021, the links are in the description box down below. ठीक है. And Vedantu Pro subscription, all the courses are down in the description box. You can just open it and enroll. Gaurav, I won't teach it in an entire elaborate manner because we've already got Epic GOC, and you see that you will enjoy. Yeah. So if something already exists, why reinvent the wheel? I might take some revision classes, I might take some question classes, I might do a modular course on that. We will see how it goes very soon. I'll let you know. Okay. Avril is saying, why do books complicated things so much, like eudiometry, etc.? It's very simple. Yes, Avril, I know it's simple, and that is why I try to give you this knowledge in the manner that my brain understands it. It's actually very simple. I have no idea why books tend to complicate it. And Albert Einstein once said that if you can't explain something in a simple manner, it means you yourself haven't understood it well. है ना, कुछ तो ऐसा बोला था. I mean, not exactly this particular statement, but on similar lines, Albert Einstein had said that if you understand something, you have the ability to make it simple. So yeah, I don't know why books are hell-bent on making things complicated. For example, if you read H.C. Verma is written in a very simple manner. Whenever you solve questions from H.C. Verma, it seems like, when you look at the solution, it seems like, oh, it was so simple. That's because it is. I don't know why a lot of books out there make things a bit too complicated. It's all logical at the end of the day. Yeah, people who are asking for Menti quizzes, let me remind you, I don't like to take Menti quizzes. थोड़ा अजीब सा लगता है मेरे को, because in Menti you can't do tough questions. Okay, in Menti you can do one word, what is the question, what is the answer kind of thing. You can't really take tough questions on Menti. Yeah, I can't sit with you and solve a question spending half an hour on it. So I don't really do Menti quizzes, because Menti quizzes are good for children. छठी क्लास के बच्चे होंगे, मजा आएगा खड़े. Arjun, okay, Richard Feynman would also have said something similar. Einstein also said something similar. Yeah, so I think a bunch of smart people have said the same thing. Yes, you can, even if you don't know nomenclature, you can start general organic chemistry. Nomenclature is just a set of instructions. Read it from the NCERT, you will be good to go. Okay. Sinister Joker, bro, the thing is, organic chemistry is already done on the channel. GOC playlist is already there. It's your wish at what speed you want to do those things. Okay. Raghav is saying, sometimes while studying I get involved and start doing lots of unnecessary research and waste time. Then don't do it, bro. Since you already know the problem, as soon as you get into it, step back and start solving questions again. ठीक है जी. चलो, सो तो भी मैं पंजाबी जे इत्थे बोलन लग पिया ना, किसी नूं समझाणी नहीं गई, फिर सारे कहणगे सर बकवास करी जांदे ने, तो मैं करना नहीं चाहता. चलो, एनीवे, Thank you so much for joining, people. Pragya, as I told you, IUPAC nomenclature, just read it from the NCERT. It's just a set of instructions. And if I start giving you instructions over here, then what's the point of, I mean, you get the idea, I hope. So chalo, that's it from my side in this class. Thank you so much for joining in. This week, the rest of this week is going to be interesting because we are going to have some different type of classes, maybe some interactive sessions, maybe some short videos on how to do things. As Aviral had suggested, please make a video on how to make reagent list for organic. So all of those ideas, keep pouring in your ideas. Leave a comment down below after the comment section is live. If you enjoyed this class, please make sure you hit that thumbs up button. Stay subscribed because lots more is still to come in chemistry on this channel. Until next time, bye bye, take care. See you soon.